Here are some notes from section 2.1. I didn't get a chance to finish all of these in class. We had a lot of stuff to do today, so I just want to finish it up. And some of this I did do in class. So these are properties of limits. And this is over on page 61 and 62 of your text. And they actually have the properties written in a little bit general form, and I kind of use some specific examples so you can kind of get the gist of what's going on, but the actual formal written down properties are on page 61 and 62. And they don't use particular numbers, but they use like variables in here. All right, so the main idea, the two basic properties we use, first of all, the limit as x approaches c of k, a constant, right? And remember, a constant is just going to be a straight line, so no matter what x is, the value is always k, so the limit as x approaches whatever of k is just going to be k, because the value is always k. And remember, this is like an f of x or a y. We usually put this in there. In other words, we're usually saying the limit as x approaches c of f of x. In this case, f of x is k. And we sometimes call f of x y in order to graph it, so y equals k, so we have a constant, a horizontal line. And the value is always the same, though it doesn't really matter. Okay? And then we had the other basic example, or basic property, the limit as x approaches c of x. Now again, this is the function f of x or y, so if we graphed y equals x, just like we graphed y equals k, we'd get the diagonal line, which is the identity function. In other words, the point 1, 1 is on the curve, 2, 2, 3, 3, 4, 4, CC, whatever. Whatever the horizontal coordinate is, the vertical coordinate will be the same, y equals x. The x and the y are the same. So the limit as x approaches c of x, well, if x is 2, it's going to be 2. If x is 3, it's going to be 3. So it's just going to be whatever this is approaching. If it's approaching c, the coordinate would be cc, so it'd be c. All right, so here's a couple of examples. The limit, okay, as x approaches 7 of 10, this is the constant, is 10. And the limit as x approaches 3 of x will be the same thing as this. Okay, so I hope that makes sense. Now these are the basic properties, and we're going to use these to simplify some examples we'll see a little bit later. So first of all, just so it'd be a little bit easier for you to see these, I just said assume that the limit as x approaches 3 of f of x equals 12, and the limit as x approaches 3 of g of x equals 3. All right? So let's take a look at how we would do the limit of the sum. And again, these are on page 61. So we're just going to say that and the statement of that theorem, or these properties, or this theorem, part 1 on page 61 would be the limit of the sum is the sum of the limits. So I'm going to write the sum of the limits, so it would be the limit as x approaches 3 of f of x plus the limit as x approaches 3 of g of x. So the limit of the sum, the limit of the sum, is the sum of the limits. All right? We don't have to prove these are just properties we were given. And then up here we know that the limit as x approaches 3 of f of x is 12, so we could put 12 plus 3, and that would be simplified to be 15. Okay, if that indeed was the case. Well, they just use letters here, and they can't simplify that, but in this case we can. Okay, and then this is property number 2. The limit of a difference is the difference of the limits. I'll write that equals the limit as x approaches 3 of g of x, I'm sorry, f of x, of f of x minus the limit as x approaches 3 of g of x, and that would equal 12. Again, the limit of the difference is the difference of the limits. So that'd be 12 minus 3, which would be 9. if indeed the limit as x approaches 3 of f of x is 12 and the limit as x approaches 3 of g of x is 3, then we can simplify that. Okay, number 3, the limit of a product, and that's going to be the product of the limit, so we could write that as the product of the limit, so that's going to be the limit as x approaches 3 of f of x times, we probably would have to use some brackets here because times the limit as x approaches 3 of g of x so again the limit of a product is the product of the limits. All right, one limit, two limits. Limit of the product, singular, is the product of the limits, plural. Okay, and then from our values we have f of x, the limit of f of x, limit as x approaches 3 of f of x is 12 times the limit as x approaches 3 of g of x is 3, and that would give me 36. Okay, and then number 4 is the constant multiplier rule. So we have the limit of a constant times a function is the constant times the limit of the function. So that's going to be equal to the constant 2 times the limit of the function. Okay, so the limit of a constant times the function is the constant times the limit of the function. And that's going to be 2 and what's this limit over here of, well, we got this up here somewhere, yeah, 12 times 12, and that's going to be 24. Okay, so these are kind of a little bit easier way to see these. You could use just the letters, and that's the more pure mathematical way. Okay, then we have property 5. The limit of a quotient is the quotient of the limits. So let's take a look at this. And this is going to hold as long as g of x isn't 0. We can never have 0 in the denominator. Never, ever. So that's going to be the quotient of the limits. So remember the quotient is our division sign, so we're going to put it over here, and that's going to be the limit. Oops. As x approaches 3, I didn't make enough room there, sorry about that, of f of x all over the limit as x approaches 3 of g of x. Okay, should have written this a little bit higher. Okay. So again, this is the limit of a quotient. There's my quotient. So the limit of a quotient is the quotient of the limits. All right. Here's my quotient, and the limit as x approaches 3 of f of x was 12, and of g of x was 3, and 12 divided by 3 is 4. Okay, and then this was over on page 62, so don't forget this. This is the limit of a function raised to a power. So the limit of a function raised to a power is the limit of the function raised to the power. So that's a little bit harder to say differently. Okay, so let's write it out. So the limit of a function to a power is the limit of the function to the power. So that's the limit as x approaches 3 of f of x all to the power. Okay? So the limit of a function to a power is the limit of the function to the power. Okay? And again, we had the fact that this was going to be 12. So that would just be 12 squared. And 12 times 12 is 144. Alrighty. And on the next video I'll show how to a couple of applications of these.